Hello and greetings to everyone. We will continue from where we ended last time with 3i, terminating and non-terminating decimals. When you hear terminating, you think of having an end. Non-terminating, that means it does not have an end. So when we talk of a terminating decimal, we are simply referring to a decimal number which has a last digit, and a non-terminating decimal is a decimal number which does not have a last digit. In such a case, there is a particular pattern of repetition of the digits. Let's write this down for the first hyphen. Any fraction which can be expressed as an equivalent fraction whose denominator is a power of 10, gives us a terminating decimal, e.g. if we take a 1/5, take a half, 3/4, and many others, we can express these fractions as decimal fractions. Continuation, terminating decimals have a finite number of digits after the decimal point. E.g., these are examples of terminating decimals. 0.1 is a terminating decimal. 0.25 is a terminating decimal. 0.671 is a terminating decimal. 10.7271 is a terminating decimal. It has a finite number of digits after the decimal point. Now we'll take the next hyphen. Any fraction which cannot be expressed as an equivalent fraction whose denominator is a power of 10 gives us a non-terminating decimal. That means after the decimal point, we have an infinite number of digits, e.g. 1/3, 1/3. We saw in our previous video that we had to express 1/3 as a decimal. The digit 3 continues repeating. Next, 5/6, 2/7, 1/9, 3/11, and many others. These are all examples of non-terminating decimals. Non-terminating decimals have an infinite number of digits after the decimal points, and have a pattern of recurring digits. So we write down non-terminating decimals by drawing a bar, means a horizontal line as such, over the recurring digit or digits. We take an example. Express the following fractions as decimals. For E, we have 1/3. E, we have 1/6. For C, we have a mixed fraction, 10 and 1/9. We take down solution. For E, we have 1/3. We are going to start by sending out 3. Put the long division sign, send in 1. 1 is less than 3. We fix a 0 here, which means the whole number part will be 0. We add a decimal point, then we attach a 0 to 10. 10 divided by 3 gives us 3. 3 times 3 gives us 9. 10 minus 9 gives us 1. We attach a 0 to 1 to obtain the number 10 for the second decimal place. 10 divided by 3 gives us 3. 3 times 3, 9. We subtract again, the result is 1. We attach a 0 for the third decimal place. 10 divided by 3 gives us 3. 3 times 3, 9. We subtract. 10 minus 9 gives us 1. We attach a 0 to 1, it gives us 10. 10 divided by 3 gives us 3. 3 times 3 gives us 9. We subtract, it gives us 1. We attach a 0 for the fourth decimal place. So you see that the division continues. It is infinite. Then here, the digit 3 will continue repeating. So we have 3, 3, 3, 3, 3, and so on. It simply means 1/3 is equal to 0.3333 with 3 dots as such. Instead of ending with 3 dots, we are simply going to write down 0.3. You can see that in this case, the digit repeating is 3. Over 3, we are going to place a bar on it. This bar simply means digit 3 is repeating. We go now to B. For B, we have the number, we have the fraction 1/6. We are going to send out 6. We bring in 1. 1 is less than 6, so we are going to fix a 0 here for the whole number part. With the decimal point, we attach 0 to 1. This gives us 10. 10 divided by 6 gives 1. 1 times 6, 6. We subtract. 10 minus 6 gives 4. 4 is less than 6, so we attach a 0 for the second decimal place. 40 divided by 6 gives us 6. 6 times 6, 36. We subtract. 40 minus 36 gives us 4. We attach a 0 for the third decimal place. 40 divided by 6 gives us 6. 6 times 6, 36. We subtract. This will give us 4. We attach a 0 for the fourth decimal place. 40 divided by 6 gives us 6. 6 times 6, 36. If we subtract, this will give us 4. So you see that the repetition continues. 6 continues repeating. So this will give us 1 over 6 to be equal to 0.1666 with 3 dots. Instead of us putting these 3 dots, we are going to identify the digit which is repeating. Then we place a bar over it. So this will give us 0.16 with a bar above. So it simply means the digit 6 is repeating. And this is the answer. We go now to C. For C, we have 10 and 1 over 9. Now this is the same as 10 plus 1 over 9. We are going to convert 1 over 9 to a decimal number. We are going to send out 9, bring in 1. 1 is less than 9, so the whole number part will be 0. We put the decimal point, that's 0 to 1, which gives us 10. 10 divided by 9 gives 1. 1 times 9, 9. We subtract, it gives 1. We are going to attach a 0 for the second decimal place. 10 divided by 9 gives 1. 1 times 9, 9. We subtract. 10 minus 9 gives us 1. We attach a 0. 10 divided by 9, 1 again. 1 times 9, 9. We subtract, gives 1. We attach a 0 for decimal place. 10 divided by 9 gives 1. 1 times 9, 9. We subtract, it gives us 1. We attach a 0. So you see that the division continues, it is infinite. Then here the digit 1 continues repeating. This will give us 1 over 9 to be equal to 0.1111 with 3 dots. That means the digit 1 continues repeating, which is the same as 0.1 with a bar above. Mixed fraction 10 and 1 over 9 will simply be equal to 10 plus 0.1 with a bar above, which is simply equal to 10.1 with a bar above 1 after the decimal point. So it simply means the digit 1 after the decimal point repeats, continuous repeating right up to infinity. We are going to move now to the next thing, IV4, which is comparison of decimals. Comparison of decimals. That means we can be given 2 or more decimal numbers for us to compare them, for us to know which one is bigger or which one is smaller. Or we can be given decimal numbers for us to arrange them in ascending order or in descending order. We write this down: to compare 2 or more decimals. The first hyphen by the margin, we start by comparing their whole number parts. The number with the bigger whole number part is greater than the other number. Greater than the other number or numbers. Let's take an example, e.g. for I, since compare 7.04 and 25.01. For us to compare these two numbers, first thing we are going to start by comparing their whole number parts. For the first number, the whole number part is 7. Second number, the whole number part is 25. 7 is less than 25. So it simply means 7.04 is less than 25.01. We take now 2i, which says compare negative 10.9 and 0.01. First, if we compare their whole number parts, for the first number, the whole number part is negative 10. For the second number, the whole number part is 0. We know negative 10 is less than 0. Therefore, negative 10.9 is less than 0.01. 3i says compare negative 24.78 and negative 14.65. We compare their whole number parts. Negative 24 is less than negative 14. Therefore, negative 24.78 is less than negative 14.65. We take now the next hyphen when the whole number parts are the same. We compare the first digits after the decimal point and the digit with a higher value gives a greater number. If the first digits after the decimal point are the same, then we will compare the second digits. If the second digits are the same, we compare the third digits, and so on. Let's write this down, still under this point. For negative decimals, the bigger decimal is the one whose first digit after the decimal point is smaller. Let's take examples on this, e.g. I says compare 0.25 and 0.12. Looking at these two decimals, you see that their whole number parts are the same, 0, 0. So we are going to compare the first digits after the decimal point. 2, 1. We know 2 is bigger than 1. Therefore, 0.25 is greater than 0.12. 0.25 is greater than 0.12. If we take 2i, it says compare negative 6.54 and negative 6.31. You see that their whole number parts are the same, negative 6, negative 6. We are going to compare their first digits after the decimal point. Here we have 5, here we have 3. So in this case, the bigger decimal will simply be the one with the smaller first digit after the decimal point. In this case, negative 6.54 is less than negative 6.31. We take 3i, says compare 251.0861 and 251.0891. In this case, you see that their whole number parts are the same. The first two digits after the decimal point of the two numbers are the same. So we are going to start by comparing their third digits after the decimal point. For the first one, we have 6. The second, we have 9. We know 6 is less than 9. Therefore, 251.0861 is less than 251.0891. We're going to take down exercises for application. Question 1 says arrange the following decimals in ascending order. Means from the smallest to the biggest. Here we have 0.4, 0.2, 0.3, 0.8, 0.1. For B we have 0.5, 1.05, 0.7, 4.14, 0.625. For C we have negative 3.07, 0.21, negative 0.11, 1.31, negative 9.45. Question 2 says arrange the following decimals in descending order. Descending, that means from the biggest to the smallest. For A we have 0.01, 0.0001, 0.3, 1.1, 1.01. For B we have 0.002, 0.0021, 0.12, 0.52, 0.412. C we have negative 4.19, 3.92, negative 0.99, 5.2, and negative 11.84. We're going to take solution. Question 1. E. For A, it says we should arrange the numbers 0.4, 0.2, 0.8, 0.1, 0.3 in ascending order from the smallest to the biggest. You'll see that their whole number parts are the same, 0, 0, 0, 0. Next, for us to get the smallest decimal number, we are going to take the one whose first digit after the decimal point is smallest. We have 0.1. 0.1 is the smallest. The next 0.2, next 0.3, 0.4, and lastly 0.8 in ascending order. For B, we have 0.5, 1.05, 0.7, 4.14, 0.625. In this case, you see that their whole number parts are different. For us to get the smallest here, if we compare their whole number parts, we have 0, 0, 0. You know 0 is less than 1, 0 is less than 4. Now for the decimals with whole number parts 0, for us to get the smallest, we are going to compare their first digits after the decimal point. Here we have 5, here we have 7, here we have 6. 5 is less than 7, 5 is less than 6. So the first one will be 0.5, followed by 0.625. Next, 0.7. We have now 1.05 and 4.14. We know 1 is less than 4, followed by 1.05, and lastly 4.14 in ascending order. We go to C. For C, we have a negative 3.07, 0.21, negative 0.11, 1.31, negative 9.45. We are to arrange these decimals in ascending order. You will see that we have negative decimals here and positive decimals. First, for the negative decimals, for us to arrange them, we know negative numbers are always less than positive numbers. For us to know the smallest, we are going to start by ignoring the negative sign. If we ignore the negative sign, then we compare their whole number parts. We know 9 is greater than 0 and 9 is greater than 3. If we attach the negative sign to the whole number parts, we know negative 9 is less than 0 and 3. Therefore, negative 9.45 is the smallest. The next, we know negative 3 is less than 0. Negative 3.07 is the next, followed by negative 0.11. Now we are left with two positive decimals. Here the whole number part is 0, here the whole number part is 1. We know 0 is less than 1, 0.21. And lastly, 1.31 in ascending order. We go now to question 2. Question 2 says arrange the following decimals in descending order. Descending means from the biggest to the smallest. For A, we have 0.01, 0.0001, 0.3, 1.1, 1.01. First thing, we are going to start by looking at the whole number parts. Here we have 0, 0, 0, 1, 1. We know 1 is bigger than 0. So we are going now to compare these two decimals which have whole number parts of 1, 1. We need to know which one is bigger than the other. So now we are going to compare their first digits after the decimal point. Here we have 1, here we have 0. We know 1 is greater than 0. It simply means 1.1 is the biggest, followed by 1.01. Next, we go here to compare these three. Their whole number part 0, 0, 0. We go move now to the first digits after the decimal point. Here we have 0, 0, 3. 0.3 is the next. Now we are left with these two. Here we have 0 after the decimal point, 0 after the decimal point. We move now to the second one, 0. We know 1 is greater than 0. The next will be 0.01. And lastly, 0.0001 is the smallest in descending order. That means from the biggest to the smallest. We go now to B. For B, we have 0.002, 0.0021, 0.12, 0.52, 0.42. For us to get the biggest, you'll see that they have the same whole number part. So you move now to the first digit after the decimal point. Here we have 0, 0, 1, 5, 4. You know 5 is greater than 1 and 4. So 0.52 is the biggest. The next is 0.412. The next is 0.12. We have to compare these two decimals. Here we have 0.002002. You will see that this one has a fourth digit after the decimal point, which is 1. Here there is no fourth digit. It simply means 0.0021 is greater than 0.002. So from the biggest to the smallest, we have 0.52 as the biggest and 0.002 as the smallest in descending order. We go now to C. For C, we have negative 4.19, 3.92, negative 0.99, 5.2, negative 11.84. We know all negative numbers are less than positive numbers. So now for us to get the biggest, we are going to compare these two positive numbers. Here the whole number part is 3, here it is 5. So the biggest will simply be 5.2 followed by 3.92. Next, move now to the negative decimals. For their own number parts, here we have negative 4, negative, here we have 0, negative 0, here we have negative 11. We know that negative 0.99 is the next. After negative 0.99, the next is negative 4.19. And lastly, negative 11.84. So from the biggest to the smallest, 5.2 is the biggest, while negative 11.84 is the smallest in descending order. And we are done with the correction of the exercises. In case you have any worries, make sure you leave your questions at the comment section. Please like the video, share and subscribe to this YouTube channel. Thank you very much for watching.